Well, good afternoon. Looks like it's a really nice day and nobody wants to come to class. I can understand that. Uh, all right. Well, today we're talking about a bunch of stuff. Just a second here and we'll see if we can't make all this work. There we go. Yes, we have a lengthy list of things to talk about today. Social engineering, phishing, ransomware, denial of service, and open source software. That's the denial of service and open source software were in the textbook. Although to be honest, there wasn't a lot in the textbook about them. So I expanded out. Besides, we're running out of lectures. And so I thought I'd start throwing in everything I wanted to cover this semester. And we'll talk about the schedule at the end of class. Oh, and to start with, does anybody have any questions? Well, hearing none, we will continue. Okay. Some of this expands a little bit beyond the normal topic of web application security, but it's all kind of related and it ought to be in there someplace. So I've put it in. Okay, social engineering. Social engineering is basically a con game. Social engineering is when you try to convince somebody to do something or tell you something that they probably shouldn't. It's been around since the dawn of time.
Come here.
Yes?
Come here.
Okay. Okay. Sorry, tech issues. Anyway, yes, so that's social engineering. It's been pretty popular. It's used a lot. A lot of people have been able to use it very effectively. Turns out that humans are probably the weakest link in the whole computer security game. A lot of users just keep clicking OK. I've seen users, my wife is one, and she'll just click OK. A lot of naive users will do that. I mean, here's my favorite example. Reformat the C drive. Oh, yeah, okay, sure. Why not? So most users do not take the steps that you should know to protect your computer. Okay. Phishing is a social engineering effort to try to get information from somebody. It's typically done by sending an email, although there are several other formats. Text and phones are becoming very popular. Basically, they ask you to click on a link or send them some information. All sorts of ways that this could be done. There are different forms of phishing. People love to make these names. Spear phishing, which is targeted at a specific individual. Regular phishing, you send it out to as many email addresses as you can find, and hopefully somebody will bite. Spear phishing, you're trying to target it towards a particular company. You try to make it look like it's inside the company so that they'll think, oh, yes, this is something we're supposed to do. Whaling attacks the big folks, the senior executives, probably because they have more access than they probably should, and they know less about how to protect themselves than they probably should. Besides, somebody asked, why do you rob banks? Because that's where the money is. Okay. Clone phishing, which is hardly a real legitimate form of phishing because most of them are this way. It tries to make an email look legitimate. In other words, they try to make it look like it came from a place it should. Of course, almost all the phishing looks like that. There's also smishing, which is phishing using text message or SMS messages. You've probably got a few of those. Phishing's become pretty big. I went out and got some information from Wikipedia. The data is from Wikipedia. The graph is mine. You can see kind of peaked in 2015. I think after that, people started to get wise. they realized that this was happening, users have become more educated and now are a little bit more resistant to that sort of stuff. But still, what is that? 500,000 incidences a year is pretty good. It's usually attacks differences. Webmail, SaaS is software as a service. We'll be talking more about that next week. Webmail is big. Financial institutions, like I said, it's where the money is. Payment systems, again. Social media only because it's so prevalently used, and others down to smaller groups. So these are who gets attacked. Frequently, it's done by imitation websites. In other words, you'll get a link in an email or somehow directed to a website which looks identical to the valid website, but it's a copy. It's quite easy to copy it because if you go to a website, you right-click, say, view source, you can just copy the source code of that website and then create your own website that looks exactly the same, adding a little bit of code in there so it steals the information instead of actually using it. Now, it turns out, of course, that if you go to a different website, that's not where you go. If you're not using HTTPS, many of the browsers these days will give warnings that you're not at a secure site, and that might frighten a user into thinking maybe they shouldn't be here. The people who do phishing are aware of that. Turns out, so they've gotten smart, and now about 85% of them use HTTPS. They've gone out and they've got themselves a certificate for their website. And so when you go out there, oh yes, it's the official website. It means this doesn't mean, if you think you're going to Facebook, they have a Facebook certificate, but they might have another one. What happens a lot is people, instead of going www.acme.com, and when you want to go to the Acme website, they'll go to something like www.acme.payments.com. Well, you're going to the payments domain, and somebody just has a computer named Acme. So it looks in the URL like it's where you want to go, but in fact, it's not. And that's a very common way to fake the URL. So it looks good, but it's not so good. Some counterfeit websites act like a proxy service in that everything you send to the website, it passes on to the valid site where you think you're going. The valid site then sends back the information that it would to the user. The counterfeit site then passes that information back on to the user. So to the user, it looks exactly like it came from the real site because it does. In other words, when they send to their user ID and password, the real site authenticates that, and it looks just like they're coming from the user. Meanwhile, of course, as everything goes through the counterfeit site, the software is saving everything. It's saving your user ID and password as it sees it, and then later on, they can log in with your user ID and password. And of course, they've seen all the information. They need other things, account numbers and stuff. That'll be there too. Also, of course, now how do you get somebody to link into that to the default system? Well, of course, an email is a really popular way. Most of them go by emails, but there's also cross-site scripting phishing. We know about cross-site scripting. We talked about that a month or so ago. And we managed to put a script in some sort of user input. And so when that's displayed on the victim's website, that will cause the browser to go to the malicious website. And then it's going to blink, blink, and then to the user, it looks like they're on the right site because they were there originally. In other words, you're signed on to acme.com, you click on something that executes some JavaScript behind that goes out to evil.com. Evil.com looks just like Acme. It displays to the user just like the because that, and of course, now they are logged in using cross-site request forgery, you're now logged into that site. So you have all the ability and the malicious website, but you're now acting in the malicious website, saving information. Okay. In addition to computers, there's many other forms of phishing. There's a telephone phishing. You probably hear that. Yeah, I get phishing phone calls all the time. This is, they tell you this is the Microsoft calling you up, telling you that your computer has a problem or your network's been attacked, all that sort of stuff. Actually, it's been entertaining sometimes to say, oh dear, what should I do? And I log in, I go through and see what they tell me to do. They have several very interesting things they tell me. A lot of the times, if you're in a Windows system, they'll tell you, go out and look at the services. They say, see, some of the services aren't running. Well, of course, some of the services aren't running. There's all sorts of services for features your computer isn't using. And so they're not running. And they claim, oh, yes, they've all been stopped by attackers. Well, of course not, but that's what they tell you. And then they tell you to go to this website and enter your information along with your credit card, please, so they can fix it. You can also, of course, get text messaging and sometimes you get that here's an error, call this number or click on this website. Now they've gotten more sophisticated. This used to be the big phishing attack. The late Nigerian banker or the Nigerian prince. They were usually the big ones. I just remember I was in a staff meeting and the dean says, "You don't have to worry about our budget. I've got money from a Nigerian banker." And so it's, now that of course looks pretty bad. Of course.
Did that really happen with one of your meetings?
Oh, well, the dean was joking, but that was a time we were getting lots of Nigerian banker emails. But then, yes, the dean goes, "Oh, we've got no budget problems. We're going to get 40 million from a Nigerian banker." That would have been nice because we could have used it. No, the dean was smarter than that. Sometimes they get a little more advanced. Here's basically the real one. Your bank wants you to send them, oh, there's some problem with security of your bank. Please send me your account number and password and they'll fix that problem. Well, of course, this is not your bank. Now, those are old. They've gotten more convincing. This one just looks better. Of course, it's the same thing, but and of course, as we know, the link here need not have to go to www.trustedbank.com. The actual link underneath the URL to where you're sent, if you click on this, could be something else, and that would be the malicious website made to look like trustedbank.com. I have a little question here. Anybody seen any interesting ones? Have you gotten interesting ones on the phone? Have you seen interesting emails? It's always entertaining to see what they're doing these days.
I think
I just got one.
Okay, yeah, okay, Addison, what do you have?
Well, the one I get mostly, it's kind of become more and more prevalent now that they're finally beginning to stop those telemarketer calls. They've been doing a bunch of those. Your USPS package has been rerouted. Click here to confirm details.
Yes.
Yeah, those are always fun.
For all of the, yes, FedEx, UPS, Post Office, yes, they broaden out. Anybody else? There were some others.
I have one.
What's that?
I just got one. They said there was a problem with my income tax return.
Oh, yes. That's common this time of year.
Yeah.
Did they say you could pay in iTunes gift cards?
I didn't even click on it because I was like, I know this is not from my bank, and that's where I got my taxes in. So I just I just deleted it. But
paying with gift cards is common. One that's come through our church is it's faked from the minister and says, "Oh, we need money for something. Just send us some gift cards." Well, it's not true, but well, of course they need money, but the email is false. Anybody else see anything really interesting?
I've seen one that's interesting. They're able to, I believe, not use HTTPS and then change their email or make their email appear as if they're Amazon.com support. Then also saying that they charge you for a product, and then you're supposed to see it and see that you didn't order that, and then respond back to them and call the number that's on the email. And the email looked exactly like Amazon.com. It's also from Amazon.com because they don't use HTTPS with certificates. So that you think, oh, okay, I got charged extra. Let me go talk to these people.
It's usually for $799. I mean,
Yes.
the ones I get are, that's a popular number. You think these people would switch it up a bit so we don't get so used to it. Anybody else? Okay. Well, there are lots of them out there. You have to keep on your toes. Yes. So be careful. Of course, remember that an organization that with which you do financial business, you've probably already given them your credit card. If you've already given it to them, you don't need to give it to them again. You know, same thing for the government. The government doesn't need your social security number. They know everything about you anyway. Okay. But as we all know, we've covered this before. The link in an email does not have to go where it says it go. In other words, here's the HTML for a link, and the text can say something, you know, www.nice.com, but in fact, when you click on it, it goes to evil.com. Now, most of the browsers or email systems I use, if you hover your mouse over the link, as you put your mouse over the link, on the lower left-hand corner, it will tell you what the link is actually going to. Unfortunately, I've noticed the phone browsers do not do this. If you're on your phone and you're hovering, it doesn't tell you. So you're kind of caught there. Okay, but we've covered this before, but you should know that. Now, I don't know if this happens for aggie.ncat.edu because that's a Gmail service, but the faculty email does not go through Gmail. It's controlled by the university. They have a Microsoft Exchange email server. And what that does is when you get an email with a link in it, the system changes your email so that the link does not point to where it was really supposed to go. Instead, it always goes to a Microsoft Safe Link server. And so it goes to the link server with a long parameter that has encoded the parameters for your original email, or excuse me, for the original link. And then the safe email server looks up in their list, see, is this believed to be safe, or most importantly, is this a known dangerous website? And if it is, it pops up a message and doesn't go to the link. And I have only once have I ever clicked on something such that the website said, this isn't a good link. And of course, so I didn't go there. Microsoft has what they call their advanced threat protection system, which is probably more marketing than reality. But this is one of the features they provide, is so that when links go to it's very much like a virus protection in your system. It has a list of known dangerous sites. And if you go to a known dangerous site, it'll protect you. Of course, if you go to a new and improved dangerous site, it doesn't know that.
Yeah, I don't know if the ones for Google do it, but Google is just really, really good already at just filtering out bad emails. Really, really, really good.
The A&T email system also filters up it. It's amazing the percentage of emails that are filtered out before they get anywhere. It's I'll try to ask our email people here, but it had been over 50%. In other words, of all the junk flying across the internet, all the emails wandering across the wires, only about half of it gets to where it goes, because the rest of it's filtered out because it's trash.
I mean, admittedly, it is a large part because it's like a really low risk kind of thing, and it's low effort as well.
Right, it's low cost. Doesn't email is generally free. Many of the email systems will charge you after a while. I know if I'm out to spam a large group of people sometime groups or organizations I belong to, I'm going to send everybody an email, which I'm supposed to do, but it will complain if I send to more than 50 people at a time.
Yeah,
I have-
plus you can create random ones pretty easily now. Just
Yeah.
temporary that lasts like 30 minutes.
Right. Yes. And that's probably an advantage as opposed to using your own.
Mhm.
Yeah. Now, so hopefully we have some laws to help protect this. I was really interested in the fact that Patrick Leahy had the Anti-Phishing Act of 2005 they produced. It did not pass. Congress chose not to pass it. I am unsure of what the legislators' complaints were, why they wanted to support phishing, but this did not pass. I can only expect that some people thought it was an overreach, that it did not, that it had other implications besides stopping phishing, that some people who were doing, things you probably don't want, but not illegal, may have had an impact on telemarketers. And they say, oh, well, we don't want that. And who knows, these servers are someplace, these servers are in your state where you can count on your legislator to support it. One of the things that's been done, backing up, I guess, excuse me. Yes. So if the government's not going to do it, some companies have been doing it. They've been filing civil lawsuits because there are a number of laws against doing illicit things with email. And so several of the companies, one year, Microsoft filed like 120 lawsuits against defendants. Some of them were John Doe's. Whoever is behind this, they want to sue them. Yes. Now, there have been some action taken. Since the first one was way back in 2004, which is about a year before Patrick Leahy's law, and they caught a teenager. And he was actually out there stealing thousands of the stuff, but they caught him. Okay, so that's phishing. I want to move on to another similar topic, and that's ransomware. Ransomware is where somehow the attacker gets software on your system through one of a variety of ways I'll talk about in a minute. And once on your system, they then encrypt your files such that your data is unreachable if you don't have the key. And so you get some terrifying message, your files are encrypted, pay here. And let's see, yes, in 2019, 2 years ago, it cost $7.5 billion. Now that's not just ransom paid, that's also downtime, because sometimes even if you're not going to pay it, recovery can take time and cause loss. There are several ways people get there. Typically, again, it's phishing. A lot of email, hijacked online ads, or where you see an ad on the side of it and you click on that, you go to that website's not where you want to go. And there was one that spread through the Windows Remote Desktop Protocol. That's the feature that allows somebody else to log into your computer and looks as if they are on your computer, and using that ability to connect, they were going through all sorts of computers that were reachable through your network.
Most of the time, these attacks are targeted towards specific companies or individuals that tend to have a lot, or tend to have data that they seem very valuable, and a reset wouldn't just fix everything.
Yes, you are exactly correct. Why do you rob banks? Because that's where the money is. They have gone against individuals, just average citizens. And they also have gone towards huge companies and charged a lot of money. It's usually just a couple $100 if they get, an average citizen, but it may be hundreds of thousands of dollars if they get a corporation. Yes.
Another thing they've been doing is a lot of smaller government agencies or government basically people is what they target to,
Mhm.
because they have a lot of valuable data. Most of their stuff is outdated, and has just been added to the online internet and computerized.
Yes, that's a spear phishing attack. They know who to attack. They're going after places that seem vulnerable, places that, yes, that have recently upgraded their systems, and the people don't really know exactly what they're doing. And remember, we have these people who've been working on this system for years, and now they got a new system, and they're not computer experts. They need computer experts, which is why, of course, we have our degree program and why we have this class. Turns out that ransomware is pretty successful. There's been somebody that, and a survey, I looked at a couple surveys, so I haven't credited an individual survey here, but once that 51% of organizations report they were attacked. So that's like half of all the organizations say, yes, they had some sort of ransomware attack. Of those attacks, of the 51% of the organizations, 73% of them were successful, in the sense that they did cause some damage. They did encrypt some files. Now, the other 27%, somehow their cybersecurity systems prevented the attack, but on 73% of the time it didn't. And of those where the attacks were successful, a quarter of the victims then paid the ransom. In other words, they paid up whatever the people wanted. Bitcoins are very popular media for payment because they are anonymous. That is the whole purpose of Bitcoins. I remember many years ago when they first introduced Bitcoins, I was teaching a computer security class, and it was an interesting concept in privacy. Well, yes, if you buy something with a check or with a credit card, a lot of organizations know where you're sending your money. Bitcoins, you don't. It's, interesting privacy. Well, it turns out, of course, most citizens don't care as much about privacy, but the drug dealers, the gun runners, the ransomware people, they care a lot about privacy, and so they want Bitcoins. Now, ransomware often is run offshore. In other words, it's if you do it in the United States, the FBI or somebody will try to get you. If you're in some country that isn't particularly friendly to the United States, and particularly if you can pay off the local government, then then you can get away with it. Some of them have they have office space, they have office fronts, they've got software development teams to help make bigger and better ransomware, and they have help desks and phone support. Of course, somebody has to negotiate the ransom. Sometimes they got to figure out how much people can pay. The really good ransomware people have done their homework. They've gone out and looked at this company's bottom line, and they've figured out how much can they afford. You don't want to charge more than they can pay, because you won't get that money. And of course, you want to get as much as you can. I really like the phone support. That's particularly useful for citizens, because if you get grandma's computer, she probably doesn't know how to pay in Bitcoins. Well, maybe she does, but somebody may not, the average citizen may not know how to pay in Bitcoins. And so you can call the ransomware hotline and they'll help you pay. Now, once you've paid, 94% of the people got their data back. In other words, they actually said, people are always concerned, well, if I pay, they won't do anything. I'll never get my data back. Well, 94% of them paid. That's because the people who do the ransomware are not complete idiots, almost, but not complete idiots. Because if they give you your data back, then if you know that 94% of the time you're going to get your data back, then you consider paying. If it turns out only 5% of the time you ever got your data back, nobody pay this. So they ruin their business if they don't let their customers trust them. So they usually pay. Now, you don't have to be a computer expert to do this. You can buy ransomware kits for just a couple $100, and the kits, it's a fill-in-the-blank sort of system, so you can do your own ransomware attacks. And if you don't want to buy the kits, don't worry, you can rent them. You can subscribe to a ransomware kit for $100 a month, and you've got all the tools you need to do this. That's sort of dangerous because now we've got people who don't know what they're doing. They're just criminals, and they're out there, and for a couple $100, they can buy in and launch a lucrative career. So what do we do about it? Well, step number one, back up your files. I'm probably the backup king. I used to have backups all over the place. You're gonna have to wait me out pretty well in order to lose all my backups. I mean, I had, my office computer. I backed it up at home. I backed it up to thumb drives. I backed it up to a cloud server in the office. I backed it up to a cloud server at home. I had CDs backed up every semester. Yeah, and then I had backups in different buildings. Yeah, maybe I'm crazy, but I didn't lose data. So we'll talk about backup later on. But if you have a good backup plan, and backup plan is more than just having backups, you have to have a plan to how to be able to recover from this. The company needs to have plans for recover from cyber attacks. And basically, the defense, instead of paying, is to say, okay, I'm not going to pay you. Clear the machine, back up your file, restore your files onto the machine, and you're ready to go. You've got your files back. You didn't have to pay. Now, the downside of that, of course, is that you lose any data that was generated that day since your last backup. Now, and of course, it may or may not be particularly easy to reset your system. Depends on how well you're backed up. I read some systems that said, or some reports that said the ransomware would be able to attack your backups. I find that questionable. Depends on what you're doing for backups. A good backup system needs to be independent of yours. As you connect, you back up, you disconnect, so that no matter what happens in your system, your backups are safe. Another good defense, of course, is the traditional rule of don't give anybody more power than they need. Don't give them only the abilities that they need to do their job. And so if they don't need to write into these files, don't give them that ability. Therefore, if they make the foolish mistake of clicking on their web link, the attacker will not be able to write into those files. And of course, like any other social engineering phishing attack, you've got to be careful about what you click on and stuff like that. Okay, so that's ransomware. Any questions about that? Big opportunity to make money. Okay, denial of service. I want to talk about denial of service. This is in the textbook, although a lot of what I'm saying didn't come from the textbook because I didn't find the textbook particularly informative. But denial of service is one of the things you can do. We want to keep information confidential, available. This is availability. We want to make sure that the systems continue to run. Denial of service is where somebody does something to make the service unavailable. We'll talk about different ways to do that. And so there's a usual denial of service, which we'll call DOS, and then there's distributed denial of service. Distributed denial of service is where the attacker uses multiple computers, sometimes thousands of computers, to perform the attack. And the whole concept is to somehow stop the system from functioning properly. There are several ways you can do that. CERT, the Computer Emergency Response Team, defines several. Basically, you're using resources. And how do you know you got there? Well, because it's not always obvious. Some of these other attacks are immediately obvious that the thing is happening. Denial of service may not be particularly visible. If all of a sudden your usage goes up from, your website's getting, 2 or 3 hits a second. Boy, that's nice and busy. You get a lot of business. And all of a sudden you're getting 100 hits a second. You might not know that if you don't have monitoring in place. What you will notice, of course, is slow network performance. You try to get to a website and you cannot. And then a large increase in certain types of email. There are multiple ways to create denial of service attacks, and I'll go over several in just a few minutes. One of them is to consume a resource, and of course, all sorts of resources you can consume. Networks. Since we're talking about web security, we're not going to go so much into, well, some of our CPU use space. There's all sorts of programs you can write to stop a computer. There's the fork bomb, where you simply go, while true, fork. And fork is the command, at least in Unix or some systems, to create a new thread. You just create zillions of threads until you've created all the threads the system can support, and then it doesn't work, and neither does anybody else's program. So that's one. Another way is to cause something to fail. In other words, you find a fault or a bug in the program and cause that program to get an error so that it stops working. And if you remember from our SQL injection assignments, there's the drop table. That was, the assignment was to prevent others from being able to log in. That would be a denial of service attack, where you go in and you delete the login table with user information so that nobody else can use the system. You can also attack configuration tables, and then there's the physical system. In other words, you can do something in the physical world, not the web world, or to keep it from working. Pull the plug, something like that. I want to talk a little bit about regular expressions, because there is a regular expression denial of service attack. This is mentioned a lot in the textbook. Okay, we've seen regular expressions here we are using a regular expression to define the format that we're going to allow for input. In other words, here is a input form. We've got an input form. It's going to be text, 85, and it's going to call show names. But before it calls show names, it makes sure that the input will be in this format. And I don't really want to go over regular expressions in detail. Some of you poor souls had me in Comp 360, where we beat regular expressions to death. And you should have also seen them in Comp 385 theory. So you should know, as a computer science student, regular expressions. And even if you're not a computer science, this is basically it. And this is just a range of letters. This one says a bunch of letters from A to Z, capital, little lowercase letters, and the brackets. Brackets or parentheses group, and the plus sign means one or more of these. There's also the star or the asterisk, which says 0 or more. Now, in most of the languages, they have a regular expression evaluator. In other words, you don't have to, your program doesn't have to figure out how to implement this. The regular expression evaluator in JavaScript will take this and apply it to the input. It typically does that by taking this input, parsing this into a non-deterministic finite state automata. Remember those from the theory class? Yes, makes a non-deterministic finite state automata. And then it goes from state to state. And because it's not deterministic, that means for a given state, there may be multiple possibilities for a given input character. And so it tries one. And if that doesn't work, it will back up and try another route. If you have lots of options, it can take a long time. So that's how they work. If you have a poorly written regular expression, it will be evaluated in the order of 2 to the n runtime. Okay, all of you computer science students should know big O of 2 to the n makes it run very slowly. For those of you with criminal justice, let's just say it's exponential time. Every time you add another character to the input, it takes twice as long to run. So it doesn't take long before it gets to be very long. Here are some examples of evil patterns. I got the evil patterns from OWASP, the OWASP.org website, which is always a good place to look whenever you're interested in information about web security. And this one. So they're all looking to successfully get a string of A's. So the A is just a letter. And so here we're just trying to find what is a pattern that will match a string of A's? And so these are all different patterns. And here is input. And it has a whole long bunch of A's followed by a letter that's not an A, the exclamation point. And so it's going to go through and try these, come to the exclamation point. Oh, it doesn't match. Back up, try the other routes. And if you do it improperly, it may cause all sorts of problems. It takes two to the end. So when you have, I didn't count how many A's I have here, but it starts to get to be a big number and things run slowly. OWASP calls these evil regular expressions. How do you know an evil regular expression? Generally, it has grouping with repetition, and inside the repeated group, there's more repetition. If you look at this, yes, you see here the plus sign is repetition, and then we repeat that. Here's repetition, repeat that. Here's this or that. That's, two of these or one of them. How do you know it's going to have to try this one and that one and repeat that? And the question mark is a anything character, so it's again repetition inside repetition. So it takes a lot. Yes. So basically, don't write regular expressions that look like that. You can do better. So say the programmer has written what they thought was sufficient regular expression, and most of the time it works. It's just that there are particular bad cases. There's that one case that takes a very long time. And if the attacker figures that out, well, they'll feed the bad case into your system. And it takes a long time. Now, if you do it in the text, the regular expression is being executed in your browser in JavaScript, then it makes your browser appear to hang. Your computer CPU utilization goes up to 100%. If, though, it goes to the server, then the server will do that. Now, of course, the server should be doing identical testing of the user input, because as we all know, that just because you test the user input and check it for validity on the client side or on your browser, what's sent to the server may not be the same. Those of us now that are skilled in using ZAP, we can change the input after it goes through the browser. As it comes out, the browser has carefully checked it, but then we muddy it up with ZAP so the actual data sent to the server is a attack. Okay. Here's basically how it's done. We have, now this is regular expression injection. Generally, the programmer writes regular expressions, but sometimes when they should be using a string match, which would be much simpler and much safer, they'll use regular expressions. In this example, which I got from OWASP, they want to see, is the user's username in their password. Many password requirements have, use upper or lowercase letters, numbers, etc. And your username cannot appear in your password. Here they are. So they just want to check to make sure that your username is not in your password. So they take your username and they're going to see, does it match in the password? Well, what if the user, again, we're talking about code injection. Instead of typing in the username, they type in something like this, where you see this is a, this is going to have repeats inside repeats inside repeats, and it's going to take a long time. So if they enter that and then a password like this, well, again, we've got into a big O of 2 to the n, and it's going to hang the system. Okay. Now, I have a question for you computer scientists. How do we fix this? Hopefully you see a poll of okay, yes, you do. Okay. So answer that if you would, please. Okay, a couple of people have fallen asleep. Anybody else want to? Oh, okay, somebody woke up. All right, that's a minute. Let's take a look at the results here. There are the results. You should be able to see that on your screen. Well, Dr. Kim, who teaches the theory class at A&T, will be happy to know that you said yes to convert the non-deterministic finite state automata to a deterministic one. If you remember from theory class, yes, there was some value in theory class that any non-deterministic finite state automata can be converted to a deterministic. That non-determinism for regular languages provides no additional power. It does, other than regular expressions, it does provide additional power, but it doesn't for regular languages. And any non-deterministic regular expression can be converted to a deterministic regular expression. And if you have a deterministic one, it'll probably run not in a big O of 2 to the n, but it'll probably be linear, big O of n. Whoever answered, use a context-free language to evaluate, I'm sorry, we're going to send you back to theory class, make you go through all that all again. And there is some value in saying the programmer must write a better regular expression. Well, they should, but in fact, a good program could fix that. Okay. Any questions about the questions? All right. Just letting you know that there was some reason that you took that theory class. See, there's something out there you have to learn. Okay. I'm going to step a little bit outside web security application because there's a major denial of service attack that's commonly done that you'll see. We'll talk about some other big ones, but this one's a network. This belongs to the network security class. And I know that Dr. Shu and others teach this in the network security, but I'll just go over it for a minute or two here. There's the classical SYN Flood attack. And it can bring down, it's brought down a lot of it. It basically works in the fact it's using up a resource. In this case, the resource is the number of ports or the number of connections that a server can support. Because the protocol keeps the port number in a 16-bit number, the largest number you can fit in 16-bit is 65,536. The number 0 is not allowed. So there's 65,535 possible different connections. And if an attacker tries to create or successfully tries to create more than that, nobody else can connect. Here's how. Okay, first of all, a little background in networking. When you do a TCP connection, TCP is a connection-oriented protocol. Internet protocol on which TCP rides is not. It's a connectionless. So the user has to tell the server, I want to connect. So it sends a message called a SYN message, S-Y-N, to the server saying, I want to connect. And the server sends back a message, oh, okay, I acknowledge that. And here's some parameters about how I'm going to connect. And then the user acknowledges that, says, well, I'm ready to connect. And now the connection has been established. And after this point, the user can start sending all sorts of data to the server and the server can respond. But there's these 3 messages that happen in the beginning in order to set up the connection. Well, what happens in the SYN attack is the bad guy starts sending many SYN, many connection requests to the server. And the server sends back a request telling the fake attacker, the fake user, that it's okay. They're going to acknowledge that. We're ready to go. But then the fake user doesn't respond. Remember, the user is supposed to respond back and then the connection is created. But now they don't. And so the server waits until the user connects. If the user doesn't connect after a certain amount of time, well, then it discards the request. But it takes a while. Sometimes that while is measured in minutes. And so for that time, the connection is tied up, even though it's not a real connection. That port number is in use because you've told the user, yes, we're going to use this port number to connect. But later, of course, when another user comes by, the good user tries to connect, there's no more ports available. All the port numbers have been, so it can't connect. And so the server becomes unusable for legitimate users. There are a couple things you can do about that. These are not web-based things. These are more network things. One, of course, is decrease the timeout required for that. Timeout should not be a minute. They should not be. They should only be a second at best, because the packets are going across the network in milliseconds. You don't need to make it too much longer than that. And also, to avoid attacks from places, network routers need to filter packets with obvious incorrect. Okay, at A&T, there's only one path into the A&T network. If packets are coming out of the A&T network, they should all have the A&T email addresses in them. If they're coming out of there and they have an address from some other network, well, that's wrong. Now, only A&T email addresses should be coming out of the A&T network. And so if you see something that's not an A&T address, it should just drop that packet, because that's an attack. But of course, minimize the amount of space that's used. A lot of these protocols and systems were set up decades ago when memory was expensive and people didn't have much memory. And they said, oh, we're just going to use we're going to reserve only a couple thousand bytes of memory for this. Well, now you've got gigabytes of memory in the machine, so don't hold back. Now there's distributed denial of service. Distributed denial of service means I'm going to use lots of computers to attack. And all those computers can be out there. And generally the idea is that somehow a attacker has gained control of a computer, not total control. It's like a virus. The user has done something, or something has occurred to that user's computer such that malware is now loaded on the computer. Now, everybody thinks, oh, my computer is running slow. It must have a virus. Well, not necessarily. Most of these people who put the malware on this want to be very secretive. They don't want you to know about it. Heaven forbid, they don't want to cause your machine to be slow, because then you'll think something's wrong. No, they try to be as stealthy as possible. Although, once the attack is underway, once it's using your computer to launch an attack against the victim, then yes, your machine may be busy because it may generate huge amounts of network traffic. It's probably sending as many packets as it can across your network. And of course, if you get thousands of computers sending thousands of packets per second, then you're going to hit the victim with millions of packets a second. There have been some really large denial of service attacks. I think the biggest one recorded was 3 years ago, 3.5 years ago, to Google. Somebody was attaching Google services. And at some point, they were getting 2.5 terabits per second of trash data coming in. That's a lot. This is Google, who's got huge network resources, because after all, they've got lots of money, and they can support that. Earlier last year, Amazon, AWS is Amazon Web Services. Now, Amazon Web Services is a cloud service, and we'll talk about clouds next week. It's a cloud service that many companies use. And so Amazon services had an attack. They managed to reduce its impact, but they said at one point they were getting 2.3 terabytes per second in a denial of service attack. And an earlier one in 2018, GitHub was attacked with 1.3 terabits per second. I like the fact there was 127 million packets a second flowing into the system. So what do you do about this? Okay, well, botnets, again, a botnet is a bunch of computers that have malware loaded on it. And the malware may be there for months, maybe years, until it's time to attack. The botnets can be controlled in multiple ways. When they wrote the software, they might have written the time and the victim right into it, hard coded it in, as programmers will know. And so at a given date and time, it comes alive and attacks it. Others have a control system. In other words, once the software is installed in your machine, the malware is installed in your computer, it sends a request off to headquarters, and headquarters will tell it when it should do the attack, or what to do. And then headquarters can later send a message back down to it telling it, or it will ask on a regular basis, because sometimes you can't communicate in both directions. So it'll ask on a regular basis what it should do. Also, some of them, the more advanced ones, allow headquarters to download new code so that the malware is very versatile. You get just the basic download there. And then, when you want to have new attacks, it will download new code to your computer and run the new code. So you can have a variety of attacks going. So we have this, I just picked this picture up off the net. We've got the biohazard symbol here. You probably all recognize the biohazard symbol. My father was instrumental in making that symbol long ago. He wasn't a graphic artist. He's marketing research. And it's got fangs, you see, it looks dangerous. Okay. All right. Internet of Things. Internet of Things is, again, a little bit straying from the concept of a web application security, which is the purpose of this course. But most of these devices are web controlled. The Internet of Things, of course, refers to all those devices in your home or business that are now computer controlled. They can network together. People have the thermostats that you can control from your phone. You can get your iPhone out, you're coming home so you can turn the heat up, door cameras. So if somebody comes to your front door, message pops up on your phone. It shows you a live picture of somebody at your front door. Of course, you can turn on the lights and all sorts of things, whatever you want to. All these things, of course, all these devices, which are generally very small, and computer miniaturization has made computers cheap. You can get computers now for just a couple bucks. I'm not talking like a Raspberry Pi, which is small and cheap. Raspberry Pi is like $35 because they're really simple. Some embedded device, it's only a couple bucks for the computer. Then you have a network access, usually Wi-Fi. And so you can plug these things on all over the place and let them control your house. It's kind of a neat feature, real computerized, real futuristic. The problem is that they're out there in controlled by homeowners who know little to nothing about computer security. Remember, folks, you're out there to protect your folks and family. You know about computer security. Help them out. They're going to need it because there's all sorts of stuff out there. And frequently, the users never change the password. These things have a network password. There's an option to change it, but nobody bothers. You just leave the default password. Why not? It's got a password. Yeah, it came with a password. I don't need to change it. But the password is well known. Anybody who buys one knows what the password is. And so now people can scan the web and look for these devices. And if they find one, they go, oh, I know what the password is, and try it. And it usually works because people don't change their passwords. Also, many of the devices are not easily updated. If a bug is discovered, say they find a security flaw, there's no easy mechanism for the manufacturer to push an update down there. It's not like your Windows desktop, where it can update your system, yes. Tomorrow is today is the second Tuesday of the month. If you're a Windows user, you should know that Windows does updates on the second Tuesday of the month. You should reboot your computer today after installing the updates. But that doesn't happen for your thermostat. So so it's usually much more difficult to update the software in your thermostat. So if a flaw exists, it may never get fixed. Yes. And so attackers can get control of a large number of these devices. Sometimes they can download software into, put malware into these little devices. And since there's thousands, maybe millions of them, they can do a very large denial of service attack against the. There have been some big ones. In 2016, there was the DIN. You might have remembered it's about 5 years ago. Well, yeah, 4.5 years ago. This took out much of the Northeast. It was an attack against domain name servers. DYN is a company that runs domain name servers. Domain name servers, if you remember from your network class, when you type in a name like www.acme.com, well, the network doesn't use that name. It uses a binary number as an address. To convert between the name and the number, your computer sends a request to the domain name server, which has a database of names and numbers, and your computer sends the name, it sends back the number, and then your computer can use the proper number. and there are some very large domain names here as well, they were attacked by tens of millions of IoT devices, little baby monitors all over the country, and all sorts of things were taking over. It took out a lot of companies. Here's a list of some of the impacted services. You can see some of them. I mean, okay, Amazon, Twitter, Visa, PayPal. Hey, these are, you take those things down, people start to notice. So yeah, a lot of them. Also, like Swedish government. Swedish government took that Starbucks. Hey, if you can't buy a Starbucks, you're really in bad shape. What are we going to do about that? That's serious stuff. Now, sometimes you get unintentional denial of service attacks. Sometimes a website can be overwhelmed by what is legitimate traffic. It's not an attacker. It's just all of a sudden they get lots of. For instance, you have a website and it gets on the news, or some other prominent website sends a link saying, "Oh, this is so great." Everybody goes out there to look at it. Well, this, little website, maybe your website, which is, gets, a couple hits an hour, all of a sudden it's getting thousands of hits a second. It may not be able to do that. One of the more interesting ones I know, several years ago, 20 years ago, when YouTube came out, the Universal Tube and Roll Form Equipment, or UTUB.com, all of a sudden, people who wanted to find YouTube were going to there because it seemed like a reasonable thought that would be. And no, it was this company that existed long before YouTube, and they were getting overwhelmed. Fortunately, the YouTube company made good. They provided the tubing company with a big heavy-duty website and helped protect them from overwhelming access. So they made them well. Okay, another source of issues that was mentioned in the textbook is open source software. Nowadays, when you build some software, you don't want to recreate the wheel. You want to use all the tools that are available. And there are a lot of cool tools out there. People use all sorts of packages to build applications, as you should, because that makes it so much easier. By using the proper packages and tools, you can put together a wonderful application. Sometimes, in an evening, that would have taken you, months if you had to do everything yourself. But the problem is, you've got open source software, which they abbreviate OSS, open source software, and you don't really know anything about that software's quality. Now, most open source software is created, of course, by multiple people out there contributing to the software, and it's reviewed by many people. But it may not be developed with the level of quality that your company wants for the software it's using. It's very hard to get something and then go out and then check it. A lot of companies use open source software. They like the price. It's usually free. And so a lot of companies go, free. That's what they want to hear. The accountants really like that. And so they want to use it. So you're using a lot of software that was not developed in the company and that they didn't pay for. And while software is reviewed and checked, it's always possible, well, not always, but sometimes possible, that one of the contributors slipped something into it that has a vulnerability that they know. And after a while, they can then attack hitting that vulnerability that they know is there because they put it there. So you have to be careful about open source software. Also, if you're a GitHub user and care of source management, source code management, then you generally have your main line of the software, and there are branches where changes are made, and the branches can be merged back into the main branch. If you take a copy, then you've got it, but maybe, say a problem is found later on, where you might want to make an update to your software that you took at one point. Well, it may be easy just to apply the patch because the software has been developed, maybe developed for a couple of years, and then, oh, there's a major flaw, a major vulnerability. Now you've got to get that patch in there. And so you may be forced, well, I'll just go back and get a whole new copy. Well, the whole new copy may have changed. It may introduce difficulties. On the other hand, you kind of have to do this. Also, as you might expect, the older a component is in your software, the older the open source software is, the longer, the further back it was since you grabbed this, then the more likely it is to have a bug or vulnerability. Okay, well, that's all I had to say for today, but I've still got to have a dozen more slides. Here's an assignment. Thought you were going to get away, huh? Okay, here's an assignment I've used before in many classes. Write exam questions. Okay, there's another exam in 2 weeks. I'll show the schedule in a minute. But on April 20th, we're having the third exam in Comp 621. I'd like you to write a question for the exam. Now, unless you're an absolute idiot, you will write a question to which you know the answer. So you need to write a good question. Oh, yes, I guess it doesn't say here. It does on Blackboard. This assignment is out on Blackboard. Blackboard says it has to be a good question. I'll cover good in that, but it has to cover these topics. Several we should call before we talk about authentication. We'll talk about cloud security next week. Yes, it has to be in one of these. You know, Tuesday, I'm just thinking now, if it's going to cover cloud security, then like cloud security lecture is talking next Tuesday, I better move this back out to maybe Wednesday next week. Okay. The deadline has just been changed. You've been given 2 more days. The deadline will now be Wednesday at noon on April 14th. Good enough? Already got that? I'll update the slides and update Blackboard shortly, but the date is due by noon on Wednesday. So you have some more time, so you can watch it. So any questions about now? A good question. How do you know a good question? You see one. A good question is not trivial, nor is it incredibly difficult. A good question does not necessarily require your memory as much as your ability to apply the information. That is, a good question asks you to do something with the knowledge instead of just telling me what I told you. In educational, there's a concept of Bloom's technology, Bloom's taxonomy. Dr. Bloom thought this up many years ago, and it has layers of questions and understanding. And the lower layer is you've heard something, and you go up, well, you can repeat back what you've heard. And at the top is you can analyze, synthesize. We want something where you can do something with the knowledge. So 3 questions. Anybody have questions about the assignment?
What formatting should we make the questions in? Are there any restrictions?
Anything you like.
So we can do true falses?
I hate true and false. True and false, even if you know nothing, you got a 50% chance of hitting it right. And hey, you guys have been students for what, 20 some years? You should have learned how to take an exam by now. You should be able to go into an exam. If you have an exam, true and false, multiple choice, in a subject you know absolutely nothing about. If you're a good student, read the question carefully and go, well, that can't possibly be true. One of the questions is all of the above, but this one and that one, can both be true. So it's got to be all of the above. Anyway, yes. So true and false, nah, not multiple choice if you must. Ideally, of course, a good question asks you to do something. A really good question, the answers can't be found on Google or anything like that. You notice in my previous exams, they were all problem-oriented. Now, they don't have to involve a website, although if you come up with a really good one, let me know and I'll make the website. But yeah, you notice my questions tend to be do something, perform this attack. Don't say, tell me how to do it. Say, do it. Your graduate students or your seniors taking a graduate class, you're doing something more than elementary school type stuff. Don't just tell me what I told you. Okay. All right. Any questions about the assignment? 3 good questions. That's all you need. You should be able to come up with 3 questions. Just go back to the slides and take a look. Okay.
One more
Yes.
question.
No.
Sorry. If we do like a question where there's like a coding component, will we just say put pseudocode, or will we need a specific?
I can flesh it out. Hey, give me
Okay.
the idea. As long as you give the idea of a question. If it's a good question, I'll make it work.
Okey-doke.
Yeah, if it needs pseudocode. Pseudocode is nice. There are a few students in this class who are not computer science majors. If you have a question that requires coding, go for it. And I'll find some way to take pity on those poor students who are not computer science. I know who you are. Okay, so yeah, that's fine. Okay, any more questions about the questions, about the assignment? It's out on Blackboard. Right now it says April 12th, but we've changed it to noon on Wednesday. All right. Okay, a couple of announcements. End of course evaluations are on Blackboard. Go out to Blackboard and answer these for all your classes. Answer them honestly and completely. These are important. I mean, most students think, who cares? Oh, well, it was classes, okay. But long ago, I used to be the department chair of computer science. Before Dr. Yuan, before Dr. Dozier, I was department chair. And I can tell you, when you are a department chair, at some point, you have to evaluate your faculty. You have to give them a raise at the end of the year. Does this person deserve a raise or not? And there's many things we look at for a raise. Do they do good research? Do they do many things? In teaching, well, how do I know how well you teach? Actually, one of the few things I have is how many complaints walk into my office and scream at me that this faculty member is terrible. I remember that, although I always let the faculty member defend themselves. But teaching evaluations help. They are important. And I can tell you, not just the chair, but the dean and other places along the university administration look at this because they have no other data about your teaching. And teaching is an important component of what we do at A&T. The faculty is supposed to do teaching, research, and service. And they can research is easy to measure. You look how many publications, how many research grants, that sort of stuff. But teaching, what do they know about how well you teach? They don't sit in my class. So the teaching evaluations count, and they're very important. So go out there and tell the truth. Also, it helps us know where we're screwing up. If I don't know what mistakes I am making, it'll be hard for me to fix them. So I look at these very carefully. All right. So please do that. It goes on until May 2nd. My anniversary. And so please make sure you do that for all your classes. Office of Career Services wants to know what you are going to do after you graduate. So if you are graduating in May, well, congratulations, you made it. Of course, you only make it if you finish this class. But assuming you do, most of you are in good shape. Then now this email has been out in several places. I don't expect you can't click on that, but find it. I'm sure the university sent you emails. It's useful. We want to know what's happening. We want to know, what are our graduates doing? Are they going to, if you're an undergrad, are you going to grad school? Are you going to a company? They have several other things they want to know. And again, it helps us know what's happening so we can improve our program. Should we be preparing students for industry or graduate school? Well, if 90% of the students go to graduate school, well, that will be more of our direction, although I don't think so. Summer classes are open. If you want to take a summer class, register now. And again, remind you, I used to be in charge of our department's course offering. At some point, the department chair has to make a decision whether a course is going to run. In other words, typically what you do is you ask the faculty who wants to teach what for summer, and you have some classes you'd like taught, and you try to find a faculty member or an adjunct faculty member to teach this class, and then you open up. Now, sometime it's not a very popular class, and it gets near the end of registration, and there's not a lot of people registered. And and the department chair will have to say, well, that class is just not going to happen. That course is, don't have enough students to run it, so we're not going to pay you to teach that class, so just forget it. So this particularly happens with graduate classes. So if you are a graduate student or even for undergraduates, register now if you want to take this one. Because if you don't register and get all your friends to register, then the class may get dropped. So make sure you register early. Okay. Here's what we are doing in Comp 621. Next week, on Tuesday the 13th, okay, Tuesday, April 13th is Monday. It should be April 12th. On April, usual time, Tuesday at 2 o'clock, we're going to be talking about web security. I got to get myself a better calendar. Maybe it's run down. And then the week after that, on April 20th, we'll be having our third exam with the questions that you provided and probably questions that I made up myself. But I will try to use some of your questions if you make good questions. Oh, and again, if you make a good question, remember the answer. And then after the third exam, we have one more lecture. I now have it listed as review. There'll probably be a few more topics in there. After the third exam, when I grade that thing, I will then put out another summary of your grades, like I emailed everybody after the second exam, and so you know how you do. And you may or may not be exempt from the final exam, which is on May 4th. And the exemption, of course, depends on whether it is statistically unlikely for you to change your grade with the final. I'll talk more about that later. But after the third exam, when I send you an email with the summary of your grades, the email will state whether you are or not exempt from the final. So we'll talk more about that later. Okay, any questions about the schedule? Know where we're going? The end is near. All right, so take a break. Tomorrow is Wellness Day at A&T. Time for rest, relaxation, and reflection. There are no assignments. I have an assignment, but it's due next Wednesday, a week from tomorrow. And yes, so if any faculty members has you doing something that's due tomorrow, you can rat them out, tell the administration about. Okay, so that's it for today. Any questions?
None at the moment.
Okay, then that's it for today. Keep watch on Blackboard. If I come up with something else that needs to be put out on Blackboard, I will do that, or maybe even more lectures if I do that too. Okay, so assignments out there, it's on Blackboard. Think of your questions, and I look forward to that. And just load them up to Blackboard and tell me have it. Okay, if that's it, then adios. Have a nice, beautiful day out there. It's supposed to be a beautiful day tomorrow. Relax and enjoy it.
Thanks, Dr. Williams. Have a good one.
Okay.
Thank you. Have a good
Dr.
one.
Williams.
Mr. Holmes, am I supposed to talk to your senior project team sometime? I guess Mr. Holmes has wandered away. Bye.